where I interrupt me, because then there will be a nice flow, hopefully, to the topic, and people will get some good value out of this video. Okay, so thank you once again so very much for being here. And here it is. So basically, we have been talking about string theory or superstring theory, however you would like to call it. This is something that got started in the 1960s after seeing sort of a bit of start, if you will, in 1919 when Kaluza and Klein solved the general relativity equations from Einstein, but did something special to it, which is that they added one extra spatial dimension. So we kind of had this predecessor or father or mother or grandmother of string theory happening sort of in the year 1919. And I will tell you right here, right now, and I have said this many times before, that I think the 20th century was a very, 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 very abundant and rich time indeed in physics, with both the relativity theories and sort of certain predictions and results even coming out from that, as well as quantum mechanics seeing sort of leaps and bounds in how well we understood things and how much we saw in terms of deeper insights into these topics in the 20th century, especially in the very early 1900s. The year 1905 was very special, and we've mentioned it a bunch. Even the sort of early 1900s, 1910s, 1920s, all of that was extremely special indeed. Extremely, extremely special indeed. I'm seeing some of the comments. Thank you so much, everybody, for being here. I'm going to say hi to you in a bit. So hang tight and be here for at least 20 to 30 minutes, because then that's when I'll take a break and read all your comments, okay? I'll get to everybody, I promise. So basically, the 1900s were very rich time. And general relativity was something that was developed, of course, after special theory of relativity by Einstein, to, of course, generalize relativity to cover more than just inertial frames, which is what we cover in special theory of relativity. So in order to allow for accelerating frames and give us a more updated theory for gravitation, he developed the general theory of relativity. So as you can imagine, gravitation is, of course, a force or a phenomena that is kind of all pervasive. It kind of affects the universe at a large scale. It's felt by us all. Anybody with mass, any object with mass will feel gravitation. So it's not one of those forces or phenomena, if you will, that goes away if you go large distance. Of course, now I should mention that at very large distance away, there is, of course, also an anti-gravity phenomena going on where the universe is expanding because of dark energy. But all of that is to say, gravitation is very important. And he gave us an updated theory for gravitation, which we kind of can say it's the physics of the large on this side, okay? And then in the same century, we also have quantum mechanics getting developed as well by a number of people, and things like the hydrogen atom, the electron, discovery of the nucleus and subatomic or subnuclear particles like the proton, and then later on the neutron. All of these were also going on in quantum mechanics. And what is more, they started to write down sort of a wave equation for matter. After kind of seeing that light has a wave and particle duality, as in it is both a wave as well as a particle. And in fact, that was given to us also by Einstein. He is one of the fathers of the old quantum mechanics because he gave us the quantum nature of light. And he also won the Nobel Prize for that, for photoelectric effect. So light having both wave and particle duality got people thinking that maybe matter or particles that we consider matter particles may also have a wave particle duality. And they started to write down equations in that way for matter. And then those were developed further. So Schrodinger's wave equation for a particle such as an electron, something small like an electron, and then taking that and taking it further by some other people who also contributed to quantum mechanics, like Max Born, like Dirac. Dirac converted the equations to include relativity, for example. Things like that were all kind of happening at the same time, together simultaneously in the 20th century. Now, the issue was that relativity on this side and quantum mechanics on this side, the physics of the very large and the physics of the very